Triangles are one of the most important polygons we encounter in geometry. They can be classified by their side lengths. Equilateral, if it has 3 equal sides. Isosceles, if it has 2 equal sides. And scalene, if it has no equal sides. Or they can be classified by their interior angles. Acute, if all its angles are less than 90 degrees. Right-angled, if it has one 90-degree angle. And obtuse, if it has one angle greater than 90 degrees. In this video, we look at the important relationships between the interior angles of a triangle, and we apply these to solve geometry problems. The most important relationship relates to the sum of the interior angles. If you cut up a triangle to form 3 separate angles, and then arrange these angles together, they'll always make a straight line. So the interior angles in a triangle add to 180 degrees. It doesn't matter the size or shape of the triangle. Adding the 3 interior angles of any triangle will always make a straight line. And we can apply this relationship to many geometry problems, like this one, where we need to find the size of angle y. These angles form a straight line, and so they add to 180 degrees. Subtracting 65 from 180, we see that angle A must be 115 degrees. And since we know the interior angles of a triangle add up to 180 degrees, we can subtract 115 and 25 from 180 degrees to give angle Y as 40 degrees. We can summarize our working, giving the geometric reasons we applied at each step using appropriate abbreviations. And there are 2 more angle relationships that apply to certain triangles. An equilateral triangle which has 3 equal sides also has 3 equal angles. So dividing 180 degrees into 3 gives 60 degrees. And an isosceles triangle which has 2 equal sides also has 2 equal angles. These base angles on any isosceles triangle will always be equal. In this problem, we need to calculate the size of angle A. In the diagram, we can identify 2 smaller isosceles triangles that make up a larger triangle. With this isosceles triangle, we know that angle B must also be 32 degrees, since these base angles are equal. We can then find the third angle in the triangle, since all 3 will add to 180 degrees. Subtracting the 2 base angles from 180 degrees gives this angle X equal to 116 degrees. Now we look for additional relationships to help us calculate angle A. For example, these angles form a straight line, and so angle Y will be 180 minus 116, or 64 degrees. And since we now know one base angle in this isosceles triangle is 64 degrees, we know the other base angle is also 64 degrees. And so the third angle, angle A, will equal 180 degrees minus the 2 base angles, giving 52 degrees. And once again, we summarize our working by writing the abbreviated geometric reasonings we used for each step.